I was recently asked by a friend to repair and rebuild this old Grasshopper beam engine that he bought on eBay. It's in a bit of a state, and at first I said, well, it's hardly worth it. But he twisted my arm, and here I am repairing it. It's quite an interesting old engine, well made really, but it's in such a terrible mechanical state. The crankshaft is slightly out of true. The eccentric that controls the valves is simply a push fit on the crankshaft, and there's no key in there. The key sheared off long ago, mainly because the eccentric throw exceeds the valve travel. I'm going to have to probably make a new eccentric to the correct throw to move the valve the required amount over the ports. Here you see me turning over the engine with some compressed air fed into it. It does actually run, but it runs like this, very lumpily, and blows past the piston at every stroke. So it's really time to dismantle this engine and have a look inside it and see just how bad it is. As I said earlier, the eccentric is wrong. There is too much travel on the valve rod, so you have to have the nuts both slack like this. This is no good at all. I'll have a look at the valve and the valve chest first to see whether I can get some more clearance in there. Here is the offending eccentric, and as you can see there's been some violence on it. Someone's tried to realign the eccentric by tapping it round with a screwdriver. It's an easy enough job to make a new eccentric sheave, and I think I'll make one that locks to the shaft with a grub screw. First of all, I'm going to need one of these. I need somewhere to put the parts that are removed from the engine so they don't get lost. Here are the parts that hold the beam to the piston rod. So now I can swing the beam out of the way to allow me to work in the cylinder region of the engine. From my experience of resurrecting old engines, the things you normally find are sheared off bolts. I'm hoping I don't find any on this engine. The engineering standard is pretty good, so I would assume that the engineer didn't shear off bolts as he fitted them. First thing to do is to take the nuts off the valve spindle, then start to remove the bolts around the cylinder head. With this engine, the valve chest cover and the cylinder cover are in one piece. I think while I'm at it I'll take off the exhaust outlet, and now speed up the video because you really don't want to sit and watch in real time me taking the thing from together. So after taking off the top assembly that supports the beam, it's time to try and remove the cylinder head. An easy way to do it is to move the piston up and down quickly, but in this case it didn't work. So the next thing to do is to very carefully, putting a minimum of pressure on, use a sharp knife, tap it with a hammer, and it will break the seal. After which, on this engine, you can remove the piston and the valve in one operation. Looking at the components, I can see that the cylinder's in very good order, and the valve's pretty good too. The first thing I want to do is to be able to look at the piston itself. So remove the part that connects it to the beam, then remove the piston from the cover assembly. Once you get the piston out, have a look at the components. They're very oily, so it's time really to give them a clean with a rag. The cylinder bore is very good indeed. I'm quite pleased about that because I have seen some bad examples, but the piston is a rattle fit in the bore. By placing it in the cylinder, you can see that there's lots of side play on it. This is down to the piston itself not being the right size, and the rings are terrible. They do actually fit in the bore, but with no resistance, no spring at all, so they're just going to pass air or steam, as you heard when I was running the engine on compressed air. I'm putting the cylinder cover back on temporarily, just to get a feel of the piston in the bore. The piston should not rock from side to side even when it does not have the cylinder cover on. The slide valve is in fairly good condition, but as a matter of course I would reface it anyway, using some 800 grade wet-to-dry sandpaper and a drop of oil on a very level surface. Here I'm using the surface of my bandsaw. Once the surface of the valve is relapped, clean it thoroughly with some solvent, then re-oil and fit it back in the valve chest. I'm temporarily putting the engine back together because I want to rule out of the equation a faulty valve. I've seen many small Stuart engines with the slide valve in the wrong way round. You can't do that on this engine though. Right, once it's back together, put some air into the engine and move the valve. You will see as you pull the valve up, the piston goes up, and as you push the valve down, the piston goes down. So the valve is fine, it's doing what it's supposed to do. Undo the cover and remove the piston, then remove the rings. Here's a ring in the bore, and it goes in the bore far too easily. It's a 1.5 inch bore engine, and this is a 1.5 inch bore piston ring. but there should be enough spring in the piston ring to close the gap, and therefore provide a seal against the steam or air. The cylinder on this engine is in very good condition, and it's very well made, so all I need to do is make a new piston and rod for it. I will cover this in the next video of the series, part 2. As the short series progresses, I hope to cover all the major problems that I find with the engine, the crankshaft, the eccentric, and finally the painting and cleaning up of the parts. And I'll show it at the end, finished. All I have to show for it at the moment is just a box of bits, but I'll get there very soon. Thanks for watching, and I hope you found it useful.